So Infura provides scalable Ethereum infrastructure, APIs, focused on the developer experience. If you're new to blockchain, you're new to Ethereum, we'll get into exactly what Infura does later once it might make a little bit more sense. So just to give us an idea, like how many people here have had experience with Bitcoin or Ethereum before? Okay, decent amount. Has anyone done any development on the blockchain? Yeah? Okay, great. So for those of you that already have some exposure, the initial slides are going to be some overview. We're just going to go over some initial blockchain concepts, and then we'll get into the specifics of Ethereum and what makes Ethereum different. So what is Ethereum? Ethereum's a blockchain, and it's a blockchain in the tradition of Bitcoin. Sometimes people call it Bitcoin 2.0. I tend not to like that phrase because I feel like it's something completely different that's not really tied to Bitcoin, but I think that phrase is just talking about it's an improvement that really brings people to a point where they can extend on what Bitcoin allowed people to do. So Ethereum's a peer-to-peer network. Somebody's going to be running a node on their local machine. People are running nodes throughout the world. All of these nodes are interconnected and sharing information. Part of that transfer of information is information related to transactions, transfer of value, and that value is on a cryptocurrency which we call Ether. So when that Ether is created, people are basically mining blocks as, sorry, give me a second, to pay for computation and storage on the blockchain. Miners are a set of nodes that on this network are basically accepting transactions, verifying transactions, and this act of verifying the transaction is what secures this network. And this whole thing started in 2014 as a fundraiser to basically power the development of this network. And the network is called Mainnet, and it was launched in 2015. So it's basically been in production, and people have been using it to transfer value for the last couple of years. Not hear me okay? I'll speak up, sorry. Oh. Oh. Is there a way that we can turn it? Oh. Okay, they're working on it. There we go. All right, is this better? Great. So this is a simple diagram just showing generally how this stuff would all interconnect. There's a representation of what could be your personal laptop, your personal workstation, connected to this global distributed network. Right now, that network is verified and secured by what are called miners that are running on this network and securing the network by verifying each transaction that's coming through it. We're going to go through this from a high level and then drill down. To be able to connect to this network, you have to be running an Ethereum client. There are a couple of different variations of Ethereum clients. One is called Geth, and the other one is called Parity. When you download and install one of these clients and run it on your workstation or your laptop, it's going to sync a version or a copy of the blockchain to your local machine. And once you have that full copy, you're able to verify any transactions that come through, and cryptographically, everything is verifiable by anybody on the network. So the client is the way that you interact with Ethereum. For you to be able to submit a transaction, to interact with a what's called a DApp, a decentralized application, you have to have an Ethereum client. And if your Ethereum client stops running, you're going to be missing some new information that's being broadcast across that network. And when you start up your laptop again, your Ethereum client started, it's going to sync back up to the most recent state and allow you to proceed with interacting with the network. So let's go a little bit more into detail on the networking aspects of this. It really starts with consensus. So a blockchain can be described as a distributed append-only database with every node having an identical copy. And that's really what's different versus any sort of financial transaction that you'll make right now with a bank or some other centralized entity. Is they're the ones in control of that database, and we as consumers are essentially trusting the data that they're returning to us, and we don't really have any way to verify it other than a particular entity's reputation. So part of the difficulty in distributed systems and in blockchains is trying to get all of the nodes to agree on what the state of this decentralized database should be. There's a bunch of different consensus algorithms in computer science that deal with this and how you can get this sort of consensus amongst a distributed network. What was revolutionary with Bitcoin and what a lot of blockchains now use is called proof of work. It's a little complex to describe exactly what proof of work is, but it's essentially the miners doing computation on these blocks to verify the transactions, and the miners get rewarded for giving their compute capacity for, again, helping to secure the network. Accounts and addresses are based on a public key cryptography. So when you install one of these Ethereum clients, it's going to generate a private key and a public key. And that public key is used to produce an address. And that address is essentially your wallet, your source for storing Ether and interacting with other things on the blockchain. Once you have that private key, you need to keep it secure, because that's the keys to your assets, the keys to your value that you're storing inside of Ethereum. So it's something that people have hardware wallets with two-factor authentication. People use other methods such as cold storage, which we'll get into a little bit later, to secure these private keys. If anyone was able to get in control of your private keys, they could take the Ether out of your account or anything like that. So transactions. Ethereum users constantly send transactions into the network through their clients. And all of these transactions are cryptographically signed using that public key that we just talked about. In asymmetric cryptography, the public key is used to sign any data that you want to send securely, and no one can tamper with it. So that's the way that Ethereum is ensuring that someone can't pretend to send a transaction and basically take money out of your account. The content of these transactions is always public also. They're stored on the blockchain. So when this network was launched 2 years ago, they were already submitting transactions, and if anybody wanted to see all of the transactions, you wanted to print out any transactions from any period of time, you're able to go on here and get this list of transactions, verify them yourself, and trace that whole history. So when you send a transaction that's passed around these nodes, it's not immediately added to the blockchain. The miners are what add the transactions to the blockchain. And the way that miners add transactions to the blockchain is based off of a concept called gas, which we'll get into in a little bit. So every few seconds, miners are getting a group of transactions. So say if all of us pulled out our phones right now, we sent a transaction to send to purchase a ticket off of Hello Sugoi. All of our transactions would start circulating around this network. And at some point, miners would start pulling these transactions off of these, what are called the pending transaction pools, and start adding them into blocks. So there's a way to set how much you're willing to pay. If you just came from the other talk, they were talking about how much it costs to send a transaction on the Bitcoin network. And That cost varies depending on how much the network's being utilized and several other factors. But based on the gas price, which is essentially the fee that you're paying to get your transaction appended to the blockchain, your transaction may get included faster or slower. And as soon as a miner includes that transaction into this block, they cryptographically verify the transaction and then submit this block to the rest of the network. Mining is, talking about this. Once they solve that specific puzzle, which is that cryptographic portion of mining, they submit the block. This block's going to propagate around the network, and as soon as other nodes get it, they add it to their copy of the blockchain, and that whole process starts over again. So if my transaction didn't get into this block, maybe it got included by another miner as they were mining the next block that was coming along, and then it'll take maybe 3 or 4 blocks before my transaction actually shows up on the network. After verifying the blocks, the nodes in the network add the new block to their local blockchain, like I said, and currently right now the blockchain is over 4 million blocks long, and it's growing. Chain data is what people refer to when they're talking about blockchain size, and currently right now, when you're talking about like the size of the blockchain, it's in the tens or hundreds of gigabytes, depending on how you're running your client. This is one of the things that people are dealing with in terms of like problems in the space that they're trying to solve is as more people start using these kinds of networks, as more people are storing this data forever on the blockchain, how does this scale? There are things called sharding that people are talking about where you don't necessarily have all of the data on your local laptop. Maybe there's data stored on other clients, and your the work on sharding is how you can do that securely without allowing somebody to tamper with the database state. So, talking about the mining rewards, every time a miner puts a block on the chain, they're rewarded with 5 Ether. That is pretty much created out of thin air. That's the value that miners are rewarded with because of giving their compute power for securing the network. Additionally, those fees that I was talking about for submitting transactions and getting them included in the block are also given to the miners. So if you were going to be mining right now and then you mined that block and all of us basically said we're able to pay a $1 fee for our tickets, you would get that 5 Ether and the equivalent in Ether of that amount in dollars. Yes? One miner, yeah. There's also this concept of what are called uncle blocks, basically blocks that get propagated across the network, and there's sort of like a race condition. Like say if you and I are both mining, we both mine the blocks at exactly the same time, and then we send our blocks out on the network. At some point, your block is going to get adopted by more nodes than mine, or maybe mine is, and that's just depending on network activity and things. And those blocks essentially are considered uncle blocks, and there's a reward related to uncle blocks that is also given. So it's not, sorry, yeah.
I want to point out something. You're saying that the Ether they come out of thin air. I think it's really important that people understand that's the one and only way that the system's been designed that new Ether comes into the system. And
Yes.
you say out of thin air, you do a bit of a disservice with a lot of people that think Ether can't do what they feel like, oh, I think it's straightforward. But so saying that thin air, you want to make sure that it's by design, that's how it is.
Yeah, okay, yeah, thanks, that's valid. So, thank you. Like he was saying, this is the way that additional Ether is added to the system. So, what we were talking about, there were some Ethereum-specific terms, but generally this was still very much blockchain general information. So what makes Ethereum different? Ethereum was created as a Turing-complete programmable blockchain. They refer to it as a world computer, where you can build decentralized applications. Unstoppable applications is also a term that I like. And it's possible to write these programs in a language called Solidity and deploy what are called smart contracts onto the blockchain. We're going to give some awesome examples of smart contracts that people are already building, so you can get an idea of why you would deploy a smart contract, the kinds of use cases for a smart contract. And again, if you're going to be executing a smart contract, it requires you to be writing to the blockchain, so you're going to have to send a transaction to the network, and you're going to be either interacting with a remote node like what Infura runs, or running your own local Ethereum node. So once a smart contract is deployed to the chain, it's immutable, and you're not able to modify it. What this allows is, if people are familiar with what's going on in the space right now with token sales, ICOs, things like that, what people are doing is they're writing these dApps, distributed applications, with smart contracts and deploying them to the chain and asking people to invest, or not necessarily invest, but to buy into this idea. And you're able to typically audit the code that people are going to be running. So it's not like you can go to your bank and say, before I send you my money, I want to see the code that you're going to be using so that I can make sure that there isn't a bug, there's not anything that's going to be compromised. People have that ability with smart contracts, and that's one of the things that really makes it powerful and really appealing to people, is that openness. When people want to basically destroy or remove a copy of a contract, it's still there, right? So there's actually broken versions of smart contracts that are still out there from things that were deployed over the last 2 years. But there's this concept of a contract suicide that basically frees up that data from the chain and basically returns any value that was stored in it depending on how the contract was programmed. So you're not going to lose money if a contract is removed. It basically will get refunded back to you. There are a lot of different patterns, unique patterns that people had to develop when developing and deploying smart contracts, just because it's very different from the typical software design paradigms that people would use. Different things that you have to take into account when your application is deployed and it's going to be immutable. Talking a little bit about the EVM bytecode solidity. Maurice, do you want to take this?
Sure. Okay, so you usually write smart contracts in a high-level language called Solidity, which feels a bit like JavaScript. That language is compiled, sort of transformed into this low-level thing called EVM bytecode, and that's what runs on the blockchain. Every client has a built-in virtual computer called the EVM, which has special instructions, and it's specially designed for executing code on the blockchain. The blockchain only deals with EVM bytecode, not Solidity. So here's a simple example of a Solidity contract. All it does is, if you send a transaction, it'll store a string, just a couple words, let's say, on the blockchain. So that requires a transaction. If you want to read it back using the getS function, you don't need to send a block transaction. You can just extract it from your local copy. So this is probably one of the simplest contracts you can write. Okay, so when we execute on the blockchain, we're dealing in the sort of programmable blockchain, we're dealing with a problem, and that's storage and computation is limited. We have to avoid wasting resources and to prevent spam and abuse. So Ethereum introduced the concept of gas. Different instructions on the EVM have different costs depending on how expensive they are. So if a transaction consists of these instructions, maybe a couple hundred instructions, so depending on what you're doing with that transaction, it can use a lot of gas or a little gas. When you submit that transaction, you specify how much you're gonna pay, or how much you're paying in Ether per unit gas. So if you're in a hurry, maybe you say you'll pay a lot, or if there's a lot of congestion in the network, you want to pay more. If you're not in a hurry, you pay less. And again, a block only has enough space for so much gas, so you can fill it up with transactions, and that's why you can't just send unlimited transactions into a block.
What is the extra price guarantee priority execution?
What
What is the extra?
Yes.
Yeah. Let's get.
what does it? Oh, paying extra for gas. What does it get you? Your transaction gets included into the blockchain quickly.
Is that priority?
Priority, yeah. Yeah, there's sort of a prevailing gas price. It sort of goes up and down depending with traffic. Usually you're only paying like a cent or 2 cents or a fraction of a cent. But again, if you're in a real hurry, if there's an ICO that you really want to get into, some people have paid hundreds of dollars for a transaction. That's unusual. Usually it's fractions of a
Is
cent.
there any guaranteed service level, or it's just that they're guaranteed?
There's no real guarantee. It's sort of like an economic incentive to include your transaction in a block, because your transaction, for various reasons, might not even reach a miner. If there's congestion, if there's issues going on, it might not even get there. So here are a few instructions and a few gas prices. As you can see, there's a wide range of prices. Some are very cheap. Some are more expensive, tens of thousands per gas. Tens of thousands of gas, for example, for every transaction, or for a contract creating transaction, that's even more. So typically, you'll pay a couple tens of thousands or hundreds of thousands of gas per transaction, and that still translates to fractions of a cent or two. And these are jumped as SHA-3 called. Those are just examples of the low-level EVM instructions. Okay, so that was the technical portion. Let's get into the fun stuff. What can you actually do with this stuff? So let's start with the most simple way of using Ethereum, and that's probably transfers. You simply transfer Ether from one account to another, from one address to another. Many blockchains allow you to do this. But even here in this simple use case, Ethereum is pretty competitive. Ethereum is the second most valuable blockchain out there. Bitcoin is number one. We think Ethereum is going to surpass Bitcoin. And one of the issues that Bitcoin is dealing with these days is you have to wait a long time for your transaction to be included in a block. Simplifying a bit, it typically takes 10 minutes on average in Ethereum. Only 15 seconds in, 10 minutes Bitcoin, 15 seconds Ethereum. It used to not be as big of a deal a couple years ago, but these days, people want faster speed. Okay, dApps, decentralized applications. These are apps that are built on Ethereum. They typically consist of one or more smart contracts, these programs that run on the blockchain, and a user interface. The user interface isn't anything special. It's the typical JavaScript, CSS interfaces that we use on the web today. dApps are one of the primary innovations enabled by Ethereum, and the ecosystem of dApps is rapidly growing. There's some really cool, crazy stuff showing up. Okay, here's another interesting feature of Ethereum, oracles. Fancy name for a simple concept. And the problem they solve is a blockchain is great at being a source of truth internally, but it doesn't really have awareness of the outside world, even the outside digital world. And by that I mean APIs, the kind of stuff programmers are used to dealing with all the time. So contract oracles are contracts plus the applications that feed real-world data into the blockchain. That might be financial data, prices of commodities, stocks, it could be weather, but really anything that's not on the blockchain that you want to pull in from the outside world. Once the oracle places the data on the chain, other contracts can query it, and they can get a view of the outside world when they're executing, and that's important. And it costs Ether to place data on the chain. The data itself is valuable if it's like financial data, so an oracle might charge a fee for the data it provides. And usually when we talk about fees, they're quite small. But over time, of course, they add up. Okay, here's another very interesting innovation of Ethereum, DAOs, decentralized autonomous organizations. It's basically you design a bunch of smart contracts, put them on the chain, and then they're interacting with external actors. Obviously people, but also in the future, more and more software and machines. And together they can form an organization. The crazy thing about this is that a lot of the functions of the organization, even the top-level, C-level management functions, can be automated and decentralized using Ethereum. So management, voting. Voting's popular because the members of the organization, that's how they can coordinate their activities. There's some proposal, you vote on it, and eventually it gets implemented. DAOs got a bit of a bad reputation last year when one of the early popular DAOs called the DAO collapsed last year. It was a little crazy, but they're making a comeback. And much of the promise, in fact, of Ethereum comes from DAOs. I think they're going to be huge in the years to come in the machine economy when we've got the Internet of Things, we've got AI, and more software and machines are interacting with Ethereum. So these organizations are going to sort of exist, possibly even independent of people. Yes, sir.
Can you give us a little insight on exactly, was it a programming error? Exactly how was it that
It was a bug in the smart contract. It was a programmer error, basically.
and what can be done differently?
Well, there's a lot of efforts going on these days around smart contract security, improving smart contract design. There's design patterns that are emerging in the programming world to structure programs safely. There's organizational things like our company Consensus is doing diligence to review smart contracts before they go public. What else? There's features being built into Solidity to make it a little more safer from a programming perspective. Anything else?
Yeah, so if you guys have been following Ethereum recently, there was another, I guess we could still call it a hack that occurred, what was it, a few days ago, and it was basically there's this concept of multi-sig wallets. So we talked about the two clients. There's Parity and there's Geth. And one of those implementations, Parity, helped people set up multi-sig wallets. And why would you want to use a multi-sig wallet? One of the things would be, say you're starting a company, you're going to be taking $10 million or the equivalent value in Ether, you're going to store it into a wallet. And how do you guarantee shared funds across your founding team or something like that? Typically, people in this space have been using multi-sig wallets. Multi-signature wallets, meaning that Maurice, myself, and our other co-founder would have these keys that could access this wallet, and you would need something like 2 out of those 3 keys to be able to access funds. Or you can do other things like implement withdrawal limits. So I could say, for us to be able to pull money out of our Infura multi-sig wallet, both 2 keys have to be used, and we're setting a withdrawal limit per day to ensure that both of us can't be bad actors and withdraw this. And that's, again, the power of the smart contract is before we would do a token sale, we would publish this as a smart contract that anyone could take a look at. So that this Parity vulnerability was in their version of what they called the enhanced multi-sig wallet. And it really shows where there's the power of this ecosystem and then how certain parts of it are still very nascent. And what was missing was basically a keyword identifier on a specific line of code or a couple of lines of code that controlled who could call that function. So there's a function that really should only ever be called by like the trusted entity, which in this case would be the smart contract, which is who are the people holding the keys to this multi-sig wallet. And you wouldn't publicly expose that so that anyone can add their own key and say, oh, hey, I like that wallet. I'm going to add my key to it and access all of their funds. That's obviously something that should be kept private. Unfortunately, because Solidity by default made functions public, that keyword was omitted, and somebody was able to access that function, add their key to a particular wallet, and basically drain the funds from this wallet. It first occurred to, what was the name of the guy? Eternity is one of the companies that was affected by this. There were a couple of other ones. I can't remember the name. The first one was the one that raised the alarm and said there's this bug that was detected in the multi-sig wallet. And as soon as that started to propagate around the development community, people with the Ethereum Foundation, what they called the White Hat Group, quickly tried to, they were working with a group of students at Cornell. The students at Cornell jumped on to help find all of the vulnerable wallets and help the White Hat Group proactively hack those people before any malicious actors could and store those funds in a secure White Hat wallet that now they're working on a secure and safe way to get those funds back to the specific owners of the original funds. So, yes?
Is there a memory limit as to how much can you put on that smart contract as far as that functionality? Let's say I want to put some type of script right on the smart contract to execute the second it's actually valid.
Yeah.
So then,
Yeah, sorry, go ahead.
Storage and computation on the blockchain is extremely limited. Obviously, you can't use it for generalized computation. It's only the specific parts that go on the blockchain, and you're limited, again, by gas. So you can only use so much gas to create a contract on the chain. It's not really a size thing. It's because, different blocks have different gas limits. It sort of ebbs and flows. But it's not a lot. It's a simple program. Typically, your contracts, a big contract is a couple hundred lines of code. All right, use cases. Ew. Tokens. This was probably the first killer dApp of Ethereum. Token exists out of contract. It represents any fungible, tradable good, typically with a fixed supply. For example, 1 billion GNT, which is Golem. Regular Ethereum accounts can own some amount of tokens. They can transfer the tokens between each other. There's a semi-official specification called ERC that describes a standard way of creating a token contract. And tokens typically have some sort of utility for a dApp or a project. You need to use them to be able to use them or consume them to be able for that dApp to work. And many of them are traded on exchanges. Some of them are quite valuable, even hundreds of millions of dollars. And here are some examples. Digix, Gnosis, Golem. And when you have tokens, you have token launches. ICOs, sometimes called ICOs, initial coin offerings. Projects have been using tokens to fund development by selling off a fraction of their tokens during a token launch in exchange for Ether. They later sell the Ether at an exchange for US dollars. In a typical token launch, the project announces the exact future block number when the launch begins. And how do we enforce that? We enforce that at the smart contract level. The launch block arrives, people send their Ether to the token contract and receive some tokens at some ratio of Ether to that token. For example, let's say 1 Ether will get you 1,000 tokens of some token. There's been a bit of a craze to launch these tokens because they're quite lucrative. Some token launches sell out only in a few minutes. One recent token launch, actually a company in LA, that we know, add token, they sold out in a single block. That's a single block worth of millions of dollars. Okay, second killer app of Ethereum was probably ENS. So just like DNS, it allows you to register a name, for example, johnsmith.eth. That maps to an Ethereum address. You saw those addresses were these long strings of letters and numbers. This improves usability, it reduces security issues when dealing with Ethereum. Another way to improve security. And there's a fairly sophisticated registration and bidding process to register a name. What you're really doing is you're registering names. It's not with a real organization. It's all on chain. It's all decentralized. It's pretty crazy. Another DApp, Gnosis, is a prediction market platform. Don't have time to get into the mechanics of prediction markets, but they use market mechanisms to forecast future events or states. Elections are a popular example. Who will win the election of 2016, let's say, or any election. Gnosis is aiming to become the world's most efficient forecasting tool with applications in finance, insurance, information governance, incentivization, sports betting, gambling, of course. It's well-funded after a recent token launch. They were quite successful. And one of their competitors is Augur, if you want to look into that. Another DApp, EtherDelta. EtherDelta is a fully decentralized token exchange. Instead of using a centralized exchange like Poloniex or something else, or Coinbase, you deposit funds into a smart contract. You always have the power to withdraw them. And all the code is open source. And this is a great example of unstoppable decentralized code. You have all these smart contracts, or a set of smart contracts on the chain, and then it's just a bunch of JavaScript and CSS that's floating around the web. It's very hard to kill something like this. Uport. So identity is kind of a big deal. It's the holy grail of the tech world, you might say. Major companies have been trying to break into this space with different levels of success. Uport wants to change that. They want to make identity self-sovereign. You fully control your identity. That's pretty profound. No organization is in control because your identity is on-chain. You manage it using a smartphone app. They have an iPhone app, not sure about Android. And then what changes when you control your identity? Well, you can have third parties come in and provide attestations for various aspects of your identity. For example, your bank might vouch for your age, your address, your credit card. Different external organizations can come in and interact with you in a way that you control. The banking integration doesn't exist yet, I don't think, but it's one example. And they support multiple personas, so you expose your identity in various ways, differently in different scenarios, while maintaining privacy.
Question, can you change your identity like the artist formerly known as Prince?
Uport supports that, yes. So a few other projects that just one-liner explanations, pretty high-profile projects in the space. So we mentioned DAOs. Aragon lets you manage organizations on the blockchain. I think they token launched recently, right? They had a successful launch. AdChain is trying to improve transparency and reduce fraud in the digital advertising industry there in Venice. They had a successful token launch. They're in a good place. Singular DTV is an entertainment studio, so they want to create a decentralized entertainment industry with rights management, project funding, peer-to-peer distribution. Another thing, First Blood, decentralized esports platform, and Ujo Music, digital rights management, enabling transparency, fairness, and profitability in the creative industries. That's Jesse over there. Okay, you want to do this?
Yeah, so, sorry, we're running short on time. So when we were talking about clients with Infura, Infura basically runs clients in the cloud so that you don't have to sync your chain locally. You always have the ability of running your own node locally, but like we were saying, sometimes you're on the resource-constrained platform, and what we do is we run nodes that are in the cloud that anybody can access through our API. And We also offer some other developer-focused tools like IPFS nodes, something else in the space for decentralized storage. And what this allows you to do is build zero-client compatible dApps. So zero client versus a light client, where a light client is something that we can go into another time, but it still requires syncing some of that data locally. Whereas a zero client really does mean that you don't have to store any of that data locally, but you still always have the ability to verify the data that we're sending you if you're using one of our APIs. And some of the users of Infura are MyEther wallet, if you're familiar with them, MetaMask, another Chrome-based browser wallet, TokenIM, which is a mobile wallet, and ENS, the ENS-powered site. If you register the domain name through them, they're also using Infura. So I know we're out of time. We can stick around and answer some questions. Happy to chat with folks. Yeah.
I will be very fast. The problem of the apps based on Ethereum is that customers should do written work in order to use them, like synchronization, etc. If we have used status network,
Yep.
it's a messenger based on Ethereum, and as founders solved that problem somehow, they created a social network which calls Steemit, and you can use it without synchronization. How they did it?
I'm sorry, how?
How they made it, like without synchronization.
So Status is using a light client. Right? I think, so was the question, how does Status IM and Steemit use the blockchain without syncing?
Yeah.
So Status IM is implementing like a light client protocol, which basically means that anybody can run this, and there's this whole specification of how you can only sync a limited amount of data from what are called light client servers running on the Ethereum network. We are not going to get that full state chain of data. You're basically getting what's called like the headers of the blocks essentially, so that you can always verify it, and you have the information to say, if I really want to dig in further, I can follow this path. But by default, it's like a trimmed down version. Better to create a platform on EOS. I'm actually not too familiar with EOS specifically. I know that they did the token sale recently on top of Ethereum, but I haven't really followed exactly what they're doing in development. Yes.
Curious, is there anything else that is in your eyes and ears that is Ethereum Lite as a platform that's emerging in the ICO space? It's not Ethereum. That's another.
Other like smart contract development platforms.
Yes.
Is
Is there anything else that's emerging or getting traction? I mean, Ethereum seems to be one.
Yeah. Tezos, yeah. I mean, there's Tezos. The Eternity project that I mentioned is also something that's trying to target being a smart contract platform. Nothing's really gotten to the point where it's as mature as Ethereum is, where you can actually see smart contracts actually deployed in use, or at least I haven't really seen any yet. So that's why I haven't.
One of my colleagues was telling me that he imagines that people would be. It's not going to be about ICOs and trading as much as it is people computing power or leveraging rendering AI or something like that.
Yeah, definitely. Yeah, okay, so there's this project called Golem that's basically doing decentralized compute. Sorry, Alan, do we need to vacate the room? Are we good? Q&A? All right. This project called Golem is a way that you can say, I have this movie that I want to render, and you can basically split up that work, and instead of throwing it out to a standard rendering farm, you could put it out on this Golem network, and that Golem network is going to distribute it. I can run a Golem worker and basically process Golem jobs, like render this frame or something like that, do some batch processing job, and get paid by basically offering my compute power. So there's stuff like that. That IPFS project that we had talked about is doing a similar thing with storage. So say you're running a server farm and you have extra storage that you're not really utilizing. Maybe you're mining Bitcoin and the rest of your storage is sitting there unutilized. You can run an IPFS Filecoin daemon that's going to basically lease that out. Yeah, right. hard forks and soft forks and things are going to be happening in the blockchain. The thing is, it's community driven, right? It's not, yeah. So, yeah, I get what you're saying.
Explaining it to new users, it's unstoppable. It's unstoppable code unless the community thinks it shouldn't happen.
Right. Yeah,
I feel like that asterisk is pretty important.
that's true. Yeah, I agree.
Will we be able to update full nodes in the future without doing forks?
What do you mean by update?
I mean, given new code base.
So, sorry, do you mean, so like the blockchain data?
Because every major change in the protocol is going to create a new blockchain, in essence, competing with others, right? Until consensus decides which one is the superior.
Not necessarily. Depends on the change, right? So, I mean, if it's something low level like changing the proof of work algorithm or something like that, then definitely it does require a hard fork. But can we get to the point where the protocol is stable enough that we don't have to really do that level of change, right?
Forking is a blessing and a curse at the same time.
Yeah.
So I have a question on the open contract. My understanding is open contract takes the balances, right, of the address and the.
Yeah. Right.
So initially they can start activities, and then it's not going to have 1 million users, there's 1 million addresses in each value that is stored in the contract. So does that, so the data size is growing on the contract, and that's growing on the blockchain. So next time I do a transfer transaction or something, because my data size of the balances is huge, does that mean I'm going to pay more gas? How does that work? How does it handle that data size growing within the contract?
Right. Go ahead.
Typically, a token has, I mean, we've seen thousands of owners, so it's not like these sizes are huge. There's no real slowdown as it grows. No, no, no. I mean, as contracts get huge, eventually, the blockchain gets bigger, and there's work being done to deal with this very big and growing 150 gigabyte blockchain. But there's no slowdown at the smart contract level.
So actually, somewhat related question. I mean, the apps that you develop, the apps are quite simple. The sophisticated apps that are coming, and what is the prediction about performance? It's a distributed network, it's going to be driven by performance and miners. Is there any discussion about how the performance is going to improve or grow over time?
Yeah, so one of the things is, like, Gnosis is actually, if you take a look, pretty complex in terms of the kinds of things that they're doing with the prediction markets and how you can tie different things, and maybe you're powering a Gnosis prediction market off of an oracle that's deployed somewhere else, and you're starting to chain these things together, right? So you have this oracle providing some data on weather, and then you can have some prediction market based on weather, right? People, I think at DevCon, their example was you can build an insurance platform on top of a prediction market by tying it to weather in one location and offsetting the risk of that insurance contract by tying it to some unrelated event somewhere else, right? And all of that is traceable through the blockchain.
But trying to predict application performance, very difficult.
Right. So application performance, we have hit some scaling issues with CPU and things like that where the EVM was not able to keep up with the throughput of transactions. So that's the kinds of things where people are talking about Casper and sharding and other things in the Ethereum space that would probably be a good thing for us to go over at like a meetup session. And that's how the community is trying to deal with scaling this.
Software protocols choices to improve performance.
Right, yeah. Sorry. All right, last. Sorry? Yeah, last question. Thanks.
Two parts of that. You mentioned about transactions happening.
Yeah.
Does that mean if I do it on my computer, the person on the other end gets the money or the user?
Yeah, so if you're using an exchange, like say you're using Coinbase or something like that, there may be some additional latency there because of any internal process that they have for sending money in and out of an exchange. But say I sent money from my wallet directly to your wallet, if it got included in one block, like the following block in that next 15 seconds, as soon as your client picked up that block, your wallet is already funded, yeah. Yeah. Yeah, go ahead, Maurice.
There currently isn't a limit on the money supply. Vitalik, one of the creators of Bitcoin, says Ethereum says it's the money supply. Ether is going to be issued as much ether as is necessary to secure the network. So it's sort of open-ended, but security is very important. On the other hand, eventually we're going to move to a different consensus algorithm. It's called proof of stake as opposed to proof of work. It's really going to help Ethereum scale, and probably issuance is going to be much lower than it is today. We don't know what that is yet, but it's about 90-something million ether in circulation.
Thanks, everyone. I think we have to wrap up, but we'll stick around in the hall if anyone else wants to ask us any questions. Thank you.